Okay, good morning to all. This is Shankar Nag. Uh, I'm one of the Enterprise DB. Enterprise DB is the Postgres company, which is uh, almost 20 years old company. So I'm certified trainer and consultant from Enterprise DB. I have close to 18 plus years of experience in IT. I started working on PostgreSQL in terms of implementation, installation, setting up high availability, load balancing, performance tuning. Okay, so these are my regular day-to-day activities. The secondary is the training. This is the course agenda, what we have set. Intro, just a basic intro, the system architecture, security, configuration, continuous archiving we are going to set up. And then we are going to see backup recovery and point-in-time recovery, then string replication, then failover, switchover, routine maintenance activity, performance tuning, and finally we are going to discuss about the connection pooling. Intro, what is Postgres? Postgres is one of the world's most top open source database management system. Postgres is ORDBMS, Object Relational Database Management System. Okay, so when we talk about the object-oriented concept, you will find the C++ concepts here. For an example, we have table partitioning. So in the table partitioning, we use a keyword called inherit. The child table or the partition table will be inheriting from the parent table. It uses a keyword called inherit. If you're coming from a C background, if you know how to code it, you can modify the source code, you can download and modify the source code. You can add your own features to the PostgreSQL and name it as NSE Postgres. That is how we have different flavors of Postgres. One is Green Plum, Netezza, and then followed by RDS, Aurora Postgres, Enterprise DB. These are the companies who have downloaded the source code, added their own features. It has been in the IT almost 25 years from now. Initially, it was named as University Postgres. Later, it got renamed to Postgres 95. Till now, we call it as Postgres SQL when they introduced fancy ISO compliant. So for an example, constraints, triggers, and so on. When they introduced in the year 96, till now we call it as Postgres SQL. Okay. So one thing I want to request is just share your introduction in the chat panel. Okay. So I will have a look in between. Just share your intro, your name, experience on database, and if you have any other database experience apart from Postgres. Okay, just share that in the chat panel. That should be fine. The foundation for Postgres, the history of Postgres is Ingress. Okay, so using Ingress, the Postgres has been developed. If you remove IN after Ingress, it has been named as Postgres. We have two versions. One is the community version, enterprise version. So using the Ingress, you can see SQL Server, Sybase, Informix, they used the foundation, Ingress as a foundation to develop their product. So the limitations with the community version. So what we don't get in the community version, we don't have cluster, we don't have monitoring tools. There is no automatic failover. It is always a manual failover. It is always a full backup, no incremental backup, no auditing tools, packages and synonyms, and you don't get any support. With the commercial version of the Postgres, the workaround for these limitation is that we have a enterprise DB XDB replication, which supports bidirectional. Then we have a monitoring tools that is PAM, Zabbix, NAGOS, PG Badger. For failover, automatic failover, we have third-party tools like Enterprise DB Failover and Rep Manager. As I mentioned, there is no incremental backup in the open source. So we use BART, Second Quadrant, uh, Barman, or PG Backrest. Now, let's say you have 100 tables. Out of 100 tables, I want to replicate only 10 tables. I want to implement the replication for 10 tables. So then we have to use XDB replication. XDB replication supports object-based replication. You can set up heterogeneous replication wherein Oracle as the master, standby as Postgres. That is the heterogeneous support what we have. For support, you can buy the SLA, service level agreement. You can sign it with Enterprise DB, Second Quadrant, AWS, and other cloud platform. Okay, so this is with respect to the features, and let's dive into the architecture of the Postgres. Before architecture, what are the general database limits? The maximum database size here, it is unlimited. Okay, it is the similar size what you have in the hard disk. If your hard disk is 10 terabyte, the database size can grow up to 10 terabyte. A table size is 32 terabyte. A row size is 1.6 TB. Field size is 1 GB. You can have unlimited rows, columns up to 1600, and unlimited index you can create. The terminology is what we use. For a table or an index, it is a relation. For a row, it is a tuple. Column is an attribute. Data, when the block is on the disk, when you do an insert, the insert will happen inside the shared memory. From the shared memory, it will be returned to the disk. In that case, it is known as page. And when you are reading the data, okay, when I say select start from table, it is going to read the block from disk to memory. In that case, we call it as buffer. Okay, so that is how it is. So this is the summary of the features and the limitations and the common database objects. So this is the system architecture of the Postgres. In this module, we will be discussing architectural summary. What is process and memory architecture? Types of utility processes. Who is the listener here? Like other RDBMS, there is a listener concept. How Postgres reads and writes the information. What is background writer cleaning scan? What happens before commit, after commit, checkpoint, directory layout, physical directory layout, and page layout. Okay, so in Postgres, if there are 1,000 users connecting, okay, so there are 1,000 users connecting, there will be 1,000 number of processes. Okay, each user connection is considered as a process. So this is my Linux server. If you have any questions, leave a question in your chat panel, or you can unmute and ask. Okay, this is CentOS operating system. So in this box, the Postgres is already installed. Switch user Postgres. I need to just start the cluster. So 1 second. So when we start the PostgreSQL server, you can see there is a parent process ID which will get launched. The parent process ID is 10029. That is the parent process ID. And these are these set of utility processes like logger process, check pointer, okay, and then wall writer, so PG writer. So these are the set of utility processes we have. Now, if I'm trying to say pSQL minus P, the port number, username as Postgres, database name as Postgres. Okay. Now for this connection, there is a process ID. PG backend PID. You can see there is a process ID called 107333. Okay, so this is the process ID which will get associated with the connection. I'll open a new terminal. PS minus EF grep Postgres. The connection, the connection what we have done, 10733, it says right now idle. It is not doing any kind of activities. We have just connected to the connection, okay, and we are not doing any activities. Now I'm trying to create a table here. So create table test connection. PG class, PG description. I'm trying to create the table with 2 million records. I'm trying to insert. Let me minimize this. Okay, I will hit this. At the back end, type this ps minus ef grep Postgres. It was idle initially. Now it started showing you that there is some table creation happening on a process called uh, not 10, 10733. Yeah, 10733. Earlier he was idle, now he's doing some activity. Once this activity gets completed, again you do ps minus ef grep Postgres, it is idle now. So likewise, if you have 100 connections, so by default, there are 100 connections. If you are trying to connect with 100 different users or 100 different machines, there will be 100 process IDs. Each connection is considered as a process ID here. That information is stored in PG stat activity. So here, these are the connections and the process IDs. Now, I'm trying to show you wait event. What is the event type we have at the back end? So for 135, it is auto vacuum process. Auto vacuum is like a reorg. It is going to perform a defragmentation. There is a logical replication. 10733 is doing a select statement. There is a BG writer, and this is idle process, and there is a wall writer. Okay, so this is what happening at the process level. Okay, so this is all about the connection request and so on. Now let's see the architecture of the Postgres, how Postgres launches the connection. Okay, so I'm going to show you that. So this is the system architecture. So we have a shared buffer, we have wall buffer, there is a process array, then we have BG writer, wall writer, checkpointer, and other utility processes. And these are the memory segments like data file, wall segments, and the error log file. Okay, now let me switch on the animation. When you start the PostgreSQL server, this is inside the RAM, inside the shared memory. There is shared buffers, wall buffers, and then process array. So Postgres is also responsible. He is a supervisor. He is responsible to start the utility processes. Plus, he's also allocating the memory segments. Okay, so this is the PostgreSQL server is started. Now, when a Postgres user is trying to connect at the top, okay, so he's trying to connect, you can see a process ID will get registered inside the process array. So we will have a list of all the processes and how the processes should be launched. So once the authentication and authorization is performed, he can perform the insert and delete any write activities. Now we are doing an insert. The data goes to the shared buffer. The transaction information will go to the wall buffers. This is the transaction logs, what we call. So I'm inserting somewhere close to 100 GB of data. That 100 GB of data is inserted in shared buffer as well as in the wall buffer. It is inserted in two different locations. Now we have the data in shared buffer as well as in the wall buffer. So the shared buffer, it is used for read and write activities. It is used for read and write activities. Wall buffer, it is for recovery. In case if my production server is crashed, I use this for the recovery purpose. Okay, now we have the data in the shared buffer and the wall buffer that is inside the RAM. Second user comes and connects. This data should be written onto the disk. So the shared buffer information, which is used for reading and writing, that information is written to the data file by a utility process called as background writer, BG writer. So BG writer is launched every 200 milliseconds, and he writes that 8K block to the data file. We have wall writer. Wall stands for write ahead logging. So there is a 16 MB file. The wall buffer information is written to the wall segments. When the 16 MB file becomes full, it creates a next 16 MB file. Okay, so this is used for recovery activity. Okay, so I'm going to stop here and let me know if you have any questions. You can unmute and talk. So team, any questions? Lakshmi, am I audible, right? Hello. Yeah, hi. Am I audible? Uh, Kaliappan and Mahadevan, do you have any questions? Let me know. You can acknowledge in the chat panel. Okay, so now we have wall writer that is writing to the wall segments. Now there is a check pointer. The check pointer is triggered every 5 minutes, and he is responsible to write the committed information. When you say commit, the checkpoint is triggered, and this information, that is the committed information, is returned to the data file, and then data file becomes stable. There is an archiver. Okay, so there is an archiver. So the archiver is responsible to copy the files from source to the destination. Okay, so it is copying from source to the destination. So the archiver is basically used for setting up a point-in-time recovery, online backup, and streaming replication. We have a stats collector. We have a log writer for the error logs, and the auto vacuum is for performing defragmentation. So the question here is, how can we say T-SQL is more efficient? We cannot say it is more efficient or it is better than other RDBMS. Like, for example, if you're comparing that with the Oracle SQL Server, you cannot say it is more efficient. And Oracle doesn't say, okay, it is better than Postgres SQL. Every RDBMS has got its own advantages and disadvantages. The architecture, what I'm showing you here, this architecture is very much similar to the Oracle SQL Server. Okay, so if you are using a Oracle server, the only difference between the Oracle and the Postgres is that the Postgres is free. Okay, it is available for free. No need to pay for anything. The same thing you will be paying in the Oracle. Okay, the same features, whatever I'm showing you, you'll for the same features you will be paying. I mean, you will be buying the license. Now, when the subscription will get started, when do you say I need a support? Okay, now let's say you are facing some issues in the Postgres SQL. Issue might be performance, or it might be replication lag. I have primary and standby. My replication is not working fine. There would be any kind of issues. Okay, so during that time, you need a support. So that is something you need to buy from the enterprise DB or from the cloud platform. Okay, so if you don't need any support, yeah, no need to buy anything. You need a support. Definitely, you need a support for a production server. So yes, you need to buy the license for it. Okay, the features are very much similar to the other RDBMS. You are buying the license there, but here you're not buying. You have to buy the support, not the product. You'll be buying the support here, Postgres. Okay, is that clear, Mahadevan? Okay. Now, this is the architecture. Now we have implemented this architecture, and in the next architecture diagram, will be uh, talking about how Postgres reads and writes. So Postgres buffer cache, that is the shared buffer, reduces the physical reads from the storage. Read the block once, then examine it many times in the cache. I have a shared buffer, then we have a disk, we have a Postgres user connecting to the PostgreSQL server. Okay, so he's trying to connect. After performing authentication and authorization, he will try to execute select star from a table. That information, if it is not present in the shared buffer, if it is not present here, it will load the block, the page from the disk to the shared buffer. From there, the Postgres user can read it. Second time, it will be much faster because that information is already in the cache. Okay, so this is the way Postgres reads. When it comes to the write, blocks are written to the disk only when needed to make room for the new blocks. So where is the block? The block is inside the memory. Okay, so inside the memory we have it. So those blocks are right. I mean, it is written to the disk whenever it is necessary, when a new user connects and when that new user says that I want to perform write activities. During that time, yes, you need space inside the memory. I'm talking about the shared buffer. So the shared buffer, so the shared memory has got a shared buffer. There is a stable database. Then we have a Postgres user connecting to PostgreSQL server. And here we are writing inside the shared buffer. The second user writes. Okay, so the multiple users are writing. Once these users start writing, and I did a commit internally calls a checkpoint. I did a commit. After commit, a checkpoint is triggered every 5 minutes, and it is returned to the stable database because I need that information, right? So I need that space, the shared buffer space for the future activities. Okay, so for future inserts, update, delete, I need the shared buffer to be cleaned up. So only then the checkpoint will be triggered and he writes that committed information. Before commit, inside the memory. Starts writing to the disk. So once you say commit, right? Once you say commit, it is not immediately written to the disk. Why? After commit, I want to read that data. Okay, after commit, I want to read the data. So that is why Postgres says that I'm maintaining this information even after commit inside the shared buffer. Okay, so that is what checkpoint will do. Now what happens if I don't say commit? We have a shared memory, we have shared buffers. There is a Postgres user, second user, and my shared buffer is almost full. Okay, there is a BG writer, and that is the background writer. So that BG writer is responsible to write the uncommitted information as well. In case if my shared buffer becomes, it will not wait for commit. It will just write that uncommitted information to the disk as well. This is how the wall files are written. There is a backend process that writes the data to write ahead logging buffers, flush wall buffers periodically on commit. That is, wall writer is launched on commit or when the buffers are full. So when the buffers are full, there is a wall writer. He is responsible to write the committed information to the data file. Or the second is if my uh, wall buffer is becoming full, right? So during that case, it's going to still write to the wall buffers, the uncommitted information. Why? Because my shared buffer is almost becoming full. Okay, that is why it is writing. So if you want to set up a online backup, what happens if my server is crash? So I need to set up a archives. So first we are writing to the shared buffers, then it is writing to the wall buffers, and from the wall buffer it is writing to the uh, wall segments, and then it is writing to the archiver process. So we need to enable the archiver process. The archiver is optional. If you need a online backup, you need a point-in-time recovery streaming replication, then enable the archive. Without archive, you will not be able to implement the DR. We need archives always. This is the conclusion of this topic. Before commit, I did just begin. I'm doing an insert on it. It is inside the memory. After commit, it is written from shared memory to the wall file. After checkpoint, it is written to the data file. So in the previous architecture, it says that flush wall buffers periodically. That is wall writer on commit. That is what here. The committed information is not written to the wall first. Then there is a checkpoint. The modified databases are written from the shared memory to the data file. This is what happens. Okay. So any questions still now, please let me know. Okay, no questions. So this is the database cluster. In this, we are going to see what is a database cluster, what is the use of these database clusters. One thing I want to check with you, do you have a system wherein the Postgres is installed? Do you have that machine and install the Postgres? Hello. Okay. So how are you practicing the labs? Do you have Linux server? No, at least do you have a Linux machine or not? Okay, fine. So I will give you the steps. You can try it somehow. So what is a database cluster? A database cluster is a collection of databases, okay, that is managed by a single server instance. A single database cluster, I have a single cluster which has got 3 different databases. Okay, it is a cluster, or you can call it as an instance in Postgres. Every instance will have its own database. So these are the 3 default databases which gets created. One is template 0, template 1, and Postgres database. Okay, so these are the 3 databases. So the database cluster is separated from a data directory and the port number. Okay, so when you create a database cluster, first thing is that you need to have the directory, create a directory, and then say port number. What is the port number you want to use? Okay, so that is how it has been separated. Now, after that, once you create a new data directory, you need to set the port number and start it. Okay, so you need to start that cluster. So using a utility called pgctl, we start and stop the cluster. I'm going to show you how to create a cluster, how to change the port number, and so on. So the first thing is that identify whether you have the Postgres installed or not. If it is not installed, you need to follow these steps. PM minus QA Postgres. So this is the first step. We need to install the Postgres. I'm installing 12. So it's going to connect the website, download, and install it. So now we need to say YS. Okay, once it is installed, we need to create instance. So let me say make directory opt nsc Postgres. Okay, then change on Postgres to nsc, switch user Postgres, and check what version you're using. So the version what we installed is 12.8. Okay, now I need to create a instance. Okay, to create an instance, we use this utility called initdb and check the version, whether it is the same version or not. Okay, so now go to initdb -d opt nsc Postgres. Inside the directory nsc Postgres directory, we have to create a directory name, subdirectory name called as nse. Okay, once the instance is created, we need to start it. So you cannot directly start it. Okay, I need to change the port number and start. So now we have created a instance. Before starting, edit this configuration file on Linux machine and then change the port number. The port number here we have is 5432. Change it to 5001 or something which is not in use. Save and close it and then start it. Okay, so we are starting it. So once that instance is started, we should connect. In order to connect, we need to say 5001. This is the instance. And to identify the instance name, you need to say obd nsc Postgres data. Okay, so this will show you the instance. The instance what we created is shown here. And on which port it is running? 5001. Under this instance, there are some set of databases, the default databases. Postgres template 0, template 1 are the databases which gets created by default. Okay, so right now we are connected to the Postgres database. So if you want to find out to which database you are connected, you need to say current database. So here it shows you the database name. So we need to find out the username. Okay, so the username is Postgres. Out of these three databases, we are connected to the Postgres database. Let me create a new database, D8 database, NSEDB. Okay, so I'm creating a new database called NSEDB. Okay. Okay, now I am connecting to NSE database as a Postgres user. It's connected. Once it is connected, we should create some tables. Create table employee. Okay, so I have created this table. In order to display the table, you need to say DT. You can see there is one table called employee under a database called NSEDB. Okay, so this is the steps we follow to create a instance, change the port number, start that instance, connect to the PostgreSQL path, create new database, connect to a new database, and then create a new table. The physical location of this table is PG relation file path. Okay, so this is the physical location of the file. So what is the file name for the table called employee? It is 16385. What is this 16384? That is the database directory name. Okay, so we have 14187, 16384, 14186, and the template one database. Okay, so then we have to insert some records. Before inserting, what is the size? It is 0. So I'm inserting only one single record. What is the size? 8 KB is the size. Okay, so this is the fixed size we have. Try to insert more number of records. So we have inserted 99 records. You can see the size is still 8 KB only. The size did not change. Okay. All these records are stored in a single page. Okay, so we have a page concept. You can check that information. Let's select. CTID star from the table name. You see, the CTID will gives us the information, the page number, and the row ID. These are the two columns in the CTID. So this is the data. So all my 100 records are in a single page. They are in a single page. Okay. Okay. Any questions till now? Please let me know. Okay, no questions. So I'm saying the other thing. So how many pages are there? There is only one single page. Within a single page, we have 100 records. Try to insert more number of records. Then run this analyze. Look for number of pages. Number of records and number of pages from PG class system table view, where is rel name is nothing but the table name. So it says that these 1000 records what you inserted, it is part of 5 pages. Okay, so it is part of 5 pages. The more number of records you insert, the more number of pages you get created. And I'm trying to create an index on employee table. Create index name, IDX EMP on employee for ID column. Okay, so I'm trying to create an index. And then in the next case, I'm trying to describe that table. So index is here. Okay, so this is what happens when you create a table with its index. What is the physical location of this index? So IDX, we have IDX EMP. Okay, so this is what the index also stores, the way the table is storing the records. And what is the file name? So we need to use this function to find the file name. So the file name for the index table is 16388. That is the file name. So this index 16388, that is the IDX EMP, is created under 16384. So I need to say select OID that name from PG underscore database. So these are the databases, and we have this directory name for these databases. So these databases, as I mentioned, created under okay, it is created under NSE Postgres data, and it is using a port 5001 is the port it uses. Okay, so this is how we create a file. I mean, the table, the index, and identifying the number of pages within the table. We have a physical file. Inside the physical file, we have data file pages, and then so this is what happens. Any questions? Let me know.
Any questions you have, please let me know in the chat panel. So I don't think you have any questions. We will see the physical location of these databases and data file. So as I mentioned, the database is created under this location. So I'm logging out. CD under this, we need to say CD table space. The base is the table space. Inside this directory, you will find 4 directories like 14187, that is Postgres database, and other respective databases you can see there. Okay, so this is what happens when you create a new database. A directory will get created. Okay. Okay. So we have a table or an index here that is under 16384. So let's say 16384. Under 16384, there is a file 16 star, 16388 is the index file name.
Okay, so it is the file name of index. What is 16385? It is the table file name. Okay, 16385 is the table file name. And it creates FSM, that is free space mapping. And there is one more file which gets created, that is VM. Visibility mapping, that is what we call it. Okay. So any questions still now? Okay. Now this is completed successfully. I need to connect back to the PostgreSQL server. And here I'm connecting to 5001 cluster. Database name is NSEDB DB. Okay, so we have some users here. There is a user called Postgres. This is the only one user what we have. So I'm creating a new user called app01 and setting the password, that is 1 2 3 4 5 6. So I have user 1 and user 2. So total there are 3 users. Let's connect to NSE database with app01 user. Create table sample ID int /dt. The table called sample, it is owned by the app01. Okay. Now reconnect to the NSE database with app02 user. We have connected and try to access that table. It is a select star from sample. Permission is denied. That is what it says. Okay, so it is there. Now, how do we grant a permission? Is not able to access it. Connect to NSE database, app01 user. So we need to say grant select on schema name. What is the table? Sample to app02 user. Okay, it is granted. Connect to app02 user. Now let's say select the sample table. Yeah, you can do it. Earlier, it was giving a permission denied error. Now he is able to access it. Why? Because we have granted a permission. Okay. And if you want to see the access privileges, it is a Z and table name. You can see app01 is having complete access on the table. He can perform insert, update, delete, and so on. App02 is just having a read permission. Okay, so this is the way we create a user, we create a table and grant a permission to that table. Okay, so any questions, let me know. Okay, no questions. So here I'm connecting back to the Postgres user. Okay, and I'm creating a schema here. Schema is a logical entity. Create a schema, something like admin, and I'm authorizing app01 to be the owner of that schema. Okay, so we created a schema under NSD database, and admin app01 is the owner. We should connect to that schema now. First, we need to connect to that user and then connect to that schema. Right now, we are connected. We are connected to NSE database as a Postgres user, right? So we should connect NSE database. And what is the username? App01 is the user. Display this schema, set search path to admin. So we are connecting to the admin schema. So inside the admin schema, there are no tables. So we don't have any tables here. So we should create a table now. So create a table, admin, sales admin, ID, int. So we are creating this table under the admin schema. Okay. Now we need to grant a permission to that admin schema. So first, we need to grant a permission at the schema level. So we should grant a permission to app02 now, because app01 is the owner. So from app01, we are giving a permission to app02. Okay. We are giving a permission to app02. That is grant usage on schema name I have to give, okay? And then give a permission at the table level. Okay, so the permission is granted at the schema level. Now you grant a permission at the table level. So for granting a permission at the table level, we need to follow the same step the way we granted at the public schema. So I need to say grant select on all tables in schema admin to the user. What is the username? App02 is the user. So we have granted it. Now you say Z schema name dot table name. App01 is having read, write, insert everything. Now we are granting a permission only for the select statement. Okay, so we are granting a permission, a select statement to the second user. Okay, so this is the way we create a schema, grant a permission to that schema, and then grant a permission at the object level and the data level. Okay, so any questions still now, please let me know. So schema here is a logical container which stores the database objects. So we have a database objects. Inside that, the information is stored. No questions? Now I'm going to show you one more case study. Let me try to create a couple of tables. Sales Q1, sales Q2. So I am creating these two tables under a admin schema. So out of these two tables, Q1 and Q2, I want to grant a permission for only a single table. So there would be a case if there are thousands of tables, you don't want to give access to all the 1,000 tables. You want to give access to only a specific table inside a schema. Okay, so out of 1,000 tables, let's say I want to give access to only 10 tables to one of the user. Okay, so that is very much possible in Postgres. And plus, the next 10 to 15 tables, you want to give access to the other user. So the steps will be, you need to grant a permission at the schema level first, that is the mandatory thing, and then grant a permission at the object level. There is one more feature in Postgres. You have a single table and you have two users accessing that single table, and I have 10 records. Okay, single table, 10 records, there are two users. You want to define a row level security. So that is the feature in Postgres. Using the row level security, I can say that you can give a permission for the first 5 rows to user 1 and the second 5 rows to the user 2. So that kind of permission or privileges you can grant it. We also have something called read-only users. If you want to create a user as a read-only, yes, it is possible. Okay, so the use case of read-only user, he will be just taking a backup, not anything else. He will not be doing the select also. Okay, so if you want to do some kind of select statement, you have to say grant select. Okay, now I want to let's say I have as a user 1, every day I'm trying to create new 100 tables. Today I'm creating new 100 tables. Tomorrow again I'm trying to create a new 100 tables. Uh, so every time or every day you should grant a permission for those newly created tables. The syntax will be like grant select on all tables in schema name to the user. So you need to grant a permission for all the tables there. So instead of that, or instead of doing a grant on everyday basis to the app02 user, you can set a permission uh, by changing the default behavior. So irrespective of as many tables the app01 creates, automatically the permission should be granted to the app02 user. Okay, so that is the default privilege settings, what we call. So for that, you need to say alter the default privileges to app01. And then you need to say at the end, grant select on table to app02. Okay, so that is how we grant it. Any questions you have, please let me know. So team, any questions still now? If you have, let me know. If you don't have questions, yeah. So this is what we have planned in day one. Okay, so team, this is the end of the topic. We can end the class now. Any questions you have now or later, you can let me know. Okay. So take care. Have a nice day. Bye-bye.